Okay, here we have another question. It says a student sets up a circuit in figure 3 shown below. Okay, sorry, figure 3 below. Figure 3 is here. We got a 10-volt battery. You got a couple of resistors. You got switch, the pathway over here. You got the ammeter. Okay, so it says the ammeter displays a reading of 0.075 amps. Calculate the potential difference across the 80 ohms resistor. So we know that it's VIR, we still use the same equation. And so we know that potential difference is the current 0.075 times 80. Okay, we use our calculator over here. So 0.075 times 80. Going to give us our answer, which is 6. Okay, potential difference is 6. Question B. Calculate the resistance of R in figure 3. So this is R over here. Okay, we know the total resistance. We know, first and foremost, we know V equals IR. And we know that the current, we know what the current is. We know the voltages. The total voltage is this, 10. The current is 0.075. And we know the total resistance, 80 plus R plus 35. Okay, now what we can do is we can rearrange it to make it R the subject. So we're going to do the first 10 over 0.075. We're left with 105 here, sorry, 115 over here plus R. And then afterwards, what we're going to do is we're going to just subtract it from it. Okay, so we're going to do minus 15 over here, minus 115 over. So we got, we can use our calculator for this. Okay, so we do 10 over 0.05, 0.075. We minus it by 115, and we should get the final answer, which is 18.3 reoccurring. So the resistance for R should be 18.3 reoccurring. Okay, the last question over here, the calculate the new current in the circuit. Calculate the new current through the circuit. Okay, sorry, we have to go to C now. C is switch X is closed. Okay, so this switch is closes. State what happens to the total resistance of the circuit and the current through the circuit. Okay, so if the switch closes, the current will not go through here. Okay, the current is like, it's kind of strange, but the current, if it's a difficult path, it will take the easier path. So the current will flow through here. So this resistance is not being used anymore. Okay, it's not in use. It's not applicable to the circuit anymore. So we're gonna say the resistance goes down. Okay, that's number one. And because the resistance goes down, the current, what happens to the current? So if we use our equation, V equals IR, when the resistance goes down, so we have V over R, the resistance goes down. When the denominator reduces, the answer for the two components that we have over here would increase. The current has to increase. Therefore, current increases. Okay, then it says calculate for D, calculate the new current through the circuit. So we need to calculate the new current now, knowing that we don't have the resistor anymore. So we know that this resistor is, so we got two resistors, okay? Total resistance, so we need to find the total resistance. So RT equals to 80 plus 18 reoccurring, okay? And so if we have this here, our final answer should be the following. It's 98.33, whatever that is, very reoccurring. So we got the resistance using V equals IR. We got the V, the total V, the potential difference is still 10 volts. Okay, and so we're going to find out what the resistance is going to be. Sorry, we're going to find out what the current is going to be. So we've got 98.33 recurring. We're just going to divide the two to find the new sort of current. And so we're going to divide the two. So V divided by R equals I. And so we can say V is 10. And we can say that we've got 98.333. And that's going to give us I. So when I pull out the calculator, I'm going to have the following. 10 divided by 98.3333. Well, that's going to give us the following. 0.1. So 0.102. Okay, so we can say it's going to be 0.102 amps. So it also proves to see that our current is actually increased